In this video, we're looking at the second derivative test, which, like the first derivative test, is going to be examining the shape and behavior of a graph to help find extrema. So the second derivative test is using concavity to help find minima and maxima. So at a critical point, if the function is concave up, then that point is a local minimum. If it is concave down, then that point is a local maximum. And if the function has an inflection point, it is neither a local min or max. And this makes sense if you kind of think about or look at the diagrams of these shapes. So a concave up function with a critical point is going to look like this. A concave down function is going to look like this with a critical point. And we can see that if it's concave up, it's a minimum. If it's concave down, it's a maximum. The only other option is not like that. It's going to be one of these or one of these, where you've got your critical point in the middle here, but you'll also notice it switches from a smiling to a frowning or from a frowning to a smiling face. So that means this also ends up happening to be an inflection point. So this is the second derivative test, basically lets you evaluate at just a point. So that's what we're going to see in the example here. So find the local extrema for the function f of x is equal to x to the fifth minus 5x cubed. So we need to find the first and second derivatives. So the first derivative is going to equal to 5x to the fourth minus the 15x squared. The second derivative is going to equal 20x to the third minus 30x. So we need to find the critical points where this first function is equal to 0. So let's rewrite that as x squared times 5 times x squared minus 3. So that means that x has a critical point at 0 and plus or minus square root of 3, because that's what's going to give all of these zeros. So now we plug those into our second derivative. X of 0 is equal to 0, and that means neither. It's not a local minimum or it's a local maximum, because that's a candidate for an inflection point, which, because of rules of math, if it's both a critical point, if both the first and second derivatives are 0, it ends up being an inflection point that's also a critical point. F double prime of negative square root 3. If we look at that, we're going to get a negative value in that first term, a negative value in the second term. So no matter how things combine together, we know this definitely has to be negative. So this is negative, which means that it is a local max. And then the second derivative of positive square root 3, we're going to get 3 to the square root 3 to the third, which is going to be 20 times 3 times square root 3 minus 30 times square root 3. And 20 times 3 is 60. 60 is bigger than 30, so this will also be a positive. So this will be a local minimum. So again, the second derivative test is just looking at how the concavity and the critical points interact and figuring out whether we've got local minimums or local maximums.